Hello everyone. Today I am presenting Smart Health AI OS, an intelligent, data driven operating system engineered to optimize medical supply chains and provide early epidemic surveillance for regional health administrations. In rural or decentralized healthcare networks, administrators face a dual crisis, which is nothing but a lack of real time supply chain visibility, which leads to critical stocks outs and delayed epidemic data, where disease outbreaks are only noticed weeks after they spread. As you can see on our main dashboard, our platform establishes a live connection to Google Firebase Firestore, pulling real time telemetry from individual primary health centers. Right now, the system flags a massive regional disparity. PHC in Maha 04 is sitting on a huge surplus of over 19,940 strips of paracetamol, while PHC in Maha 12 has plummeted to a critical stock level of only 130 strips. To solve the problem of data logging at the grassroots level, where clinic workers are overwhelmed and cannot deal with complex software forms, we built a multimodal voice entry engine. Instead of requiring manual typing, a healthcare worker simply records a native dialect heavy voice note, which can be a mix of Hindi, English, or any language. We choose to bypass rigid traditional speech to text APIs. Instead, the raw audio binary is streamed directly into the Gemini 2.5 Flash multimodal engine. Gemini simultaneously handles dialect transcriptions, filter outs conversational filter, normalizes brand names with the generic variants, and outputs a structured JSON schema. This schema directly triggers an atomic server side increment in our Firestore database, updating the telemetry balances instantly without any risk of concurrent data overwrites. But reactive data is not enough. To make this system truly proactive, we implemented a predictive material depletion forecasting model. When we run our analytics, the system does not just look at the current volume, it calculates the velocity of the consumption by analyzing historical burn logs. Look at PHC Int Maha Note 12. Even though we just added stock, the mathematical forecasting engine detects an accelerating consumption velocity of over 42 strips a day. The system cross references the velocity against environmental factors using LLM reasoning. It projects that this clinic has less than 3 days of remaining operational runway, automatically triggering a high priority rate critical risk status to intercept a total stockout before it physically occurs. This sudden acceleration in medicine burn rate is explained by our next layer, automated epidemiological biosurveillance. By processors raw, unstructured daily doctors' notes across clinics, the engine performs spatial temporal pattern matching. It successfully connected the dots between isolated high fever and low platelet cases across different clinics, identifying a high confidence dengue outbreak cluster week before formal laboratory statistics would match it. Finally, our AI prospective action engine takes all this data, the inventory imbalances, the consumption velocities, and the outbreak map to generate optimized geospatially constrained operational logistic commands. It directs the district medical officer to transfer exactly 1500 strips from the surplus at node 04 to the outbreak zone at node 12, calculating the local logistic cost and defining an immediate containment strategy. To ensure enterprise stability, the entire platform has been using Docker with a multi stage production build, making it cloud ready and capable of continuous deployment in real world environments. The prototype demonstrated today focuses on the core AI capabilities, real time inventory, intelligence, multimodal voice injection, predictive stock forecasting, and AI driven resource redistribution. In the complete production scale platform, these capabilities are integrated with additional operational modules, including patient footfall and queue management, doctor attendance tracking, bed management, diagnostic test availability, citizen facing health center applications, emergency notification, and several other administrative services. These modules are part of the full ecosystem but are outside the scope of these short demonstrations. By combining multimodal AI, real time cloud synchronization, predictive analytics, or intelligent decision support, Smart Health AI OS transforms healthcare management from reactive reporting into proactive data driven governance, helping administrators anticipate problems, optimize resources, and better healthcare outcomes. Thank you.